Okay, in this video clip, we'll be talking about evaporation, condensation, and saturation. So we know what is evaporation, condensation, and saturation. So we'll be talking actually some facts about evaporation, condensation, and saturation. So suppose we were able to observe individual water molecule in a beaker, as like the illustration is coming over here. So something like that. What would we see are water molecule jiggling, bouncing, and moving about. However, we would also see that the molecules are not all moving at the same speed. The speed would be different. Some are moving much faster than other. At the surface, molecule with enough speed would occasionally break away from the liquid surface and will enter into the air above. These molecules changing the form, the liquid state into the vapor state, are evaporating. That's also called evaporation. While some water molecules are leaving the liquid, other are returning, and these returning are condensing. Condensing as they are changing from a vapor state to a liquid state. So those are evaporation and condensation. When a cover is placed over the beaker, after a while, the total number of molecules escaping from the liquid, which is evaporating, is balanced by number returning, which is called condensing. When this condition exists, the air is said to be saturated with the water vapor. Under saturation condition, for every molecule that evaporates, one must condense and no net loss of liquid or vapor molecule results at the end. If we remove the cover, what would happen? If we remove the cover and blow across the top of the water, some of the vapor molecule already in the air above will be blown away, creating a difference between the actual number of vapor molecule and the total number of required for the saturation. This helps prevent saturation from occurring and allow for a greater amount of evaporation, just as if wind were blowing atop on the water surface. Wind therefore enhance evaporation. So the temperature of the water also influence evaporation. How is that? All else, if we are considering all the situation is being equal, warm water will evaporate more readily than cool water, because when water molecules are heated, they will speed up. At higher temperature, a greater fraction of the molecule have sufficient speed to break through the surface tension of the water and dip off into the air above. In other words, we can say the warmer the water, the greater the rate of evaporation. So that's the relationship. If we could examine the air above in the water, we would observe the water vapor molecule freely darting about and bumping into each other as well as into the neighboring molecules of oxygen and nitrogen. So we know all these things, but how the condensation happens? Condensation always gather the water molecule always be around some sort of dust. A droplet of water cannot be formed without any very little tiny dust. So all the droplets that come from sky are behind a droplet. Okay, we can see that the condensation is more likely to happen when the air is cool and the speed of the water vapor molecule decreases. As the air temperature increases, condensation is less likely because most of the water vapor molecule have sufficient speed to remain as water vapor. As we will see in this and other following the chapters, condensation occur primarily when the air is cool. But is that the only things that we should know? No, there is the exceptions. We'll be talking. Even though condensation is more likely occur when the air is cool, it is important to note that no matter how cold the air become, there will always be a fewer water vapor molecules with sufficient speed to remain as vapor. It should be apparent then that the same number of water vapor molecule in the air. The saturation is more likely to occur in the cool air than the warm air. This fact often leads to the statement that warm air can hold more water vapor molecule before becoming saturated than the cold air. Or simply we can say the warm air has a greater capacity for water vapor than the does cold air. At this point, it is important to realize that although these statements are correct, the use of such word hold or capacity are misleading when describing water vapor content, as air does not really hold water vapor in sense of making room for it. So by now we know that's actually, I would not say to think more about this hold or capacity word, but it is the normal sense that we can talk about evaporation, condensation, saturation. So evaporation only happens when this molecule can escape the liquid form to vapor form, and condensation happens when temperature decrease, then relative humidity increase, and when it reach out 100% of the relative humidity, then condensation happen. And when it reach out 100% relative humidity, that's mean that air has maximum capacity of holding the water vapor at that temperature. That's called saturation. Thank you.